Hi, welcome you all to Home Tech Systems. I'm here with you to convey and bring you my experiences of installing an off-grid solar system, review it and provide some knowledge based on my experiences. Let's go to the video. This video is about 1.4 kilowatt off-grid solar system I installed in my home. Now I wish to give you my experience and tell you the importance of inverter that you need to select for the system's performance and avoid late worries. I installed 1 kilowatt off-grid solar system in 2019. It was 24 volt system having two numbers of 200H at C10 batteries. Initially it was 3 panels of 350 watt. After 2 years in 2021, I added one more panel of 395 watt, so capacity increased to 1400 watt, and I also increased solar panel height as you can see. Dear friends, in our life we cannot have a home without electricity. Investing some money for generating electricity can reduce or avoid electricity bills from utility supplier, and it is a pleasant feeling that we can produce our own electricity. An important part of any solar system is an efficient inverter. A good designed inverter will help our system work efficiently. If not, it will worry us later. Here I am going to discuss an international Chinese branded off-grid hybrid inverter. Initially, I used a 2500 VA inverter from a local company. It did not support many features that a branded inverter provides. Power factor was not mentioned anywhere. If it was 0.7, maximum load need to be 1750 watt, but maximum load was actually below 1500 watt. In every inverter, when overload occurs, inverter will disconnect load to protect itself. One time when we switched on accidentally two loads of 1000 watt each, inverter transformer winding insulation burned by heat and burning smell spread all over there. It means inverter's overload protection neither existed in the inverter nor worked. From that time, inverters started to make a humming noise, especially when we connected to higher watt devices. So finally, I decided to purchase a branded inverter with three things in mind. Firstly, minimum 3 kilowatt load capacity working in 24 volt battery. Otherwise, I have to invest more in batteries to make it 48 volt. Secondly, inverter must be controlled and accessed remotely by mobile applications. Third thing, inverter to be wall mounted. Most of the branded wall mounted inverters available in India are on grid inverters like Howells, Growwatt, Vari, Fronius and others, and off grid inverters are not available. These three things in mind, I could not find an inverter in Indian market meeting my budget. After I discussed with many inverter suppliers in China, I decided to buy a Chinese inverter brand called PowMr, and it was delivered in April 2022 and installed on the same day. Now we will talk about the main specifications of this inverter. It has 3.5 kilowatt load capacity, power factor is 1. So actual power for load and apparent power are the same. This inverter supports 24 volt battery storage. It supports a 5 kilowatt solar panel capacity, which actually is huge. As we know, charging two batteries does not require this much capacity, but we can add two more batteries in parallel or use extra electricity directly from panel to operate something like AC. It has 100 ampere solar charger. We can access and configure the inverter remotely by software. It supports maximum VOC 500 volt. MPPT voltage range is between 120 and 450 voltage. This inverter is wall mounted. Here we are unboxing the inverter. You can see it marked as 24 volt DC. I have additionally purchased Wi-Fi module with its cable to connect it to inverter. Now here you can see the screen and menu buttons, dust filter, inverter switch. AC input and inverter output connections. There are two heat reducing fans, battery input port positive and negative, PV input port positive and negative. So here I am going to introduce you how this branded inverter is working and performing since its installation in April 2020. Inverter manual recommends to install protection devices like MCB in three places. The first one is between inverter and battery. The second one is between inverter and AC input, and third one is between inverter and AC output, that is load. As we can see, we have installed three MCBs to give protection for both inverter and equipments. The first one is DC MCB of 125 amps. We have installed two single pole MCBs for DC protection, and this one is MCBs for AC input output protection. This one is to give protection from AC utility power, which is KSEB. This one, as we can see, we have 25 amps. And second is to give protection between load and inverter. This one we have 32 amps. Now we will see how we do connections of AC input output, battery and PV cables with inverter. See this, here we will connect AC input cables from grid power to inverter. This one AC output from inverter we need to connect to load at home. This connector is for earthing. It is necessary to connect the inverter to earth. Otherwise sometimes we will get small shock from inverter, like we touch this screw, for example, or even at the battery terminal. Since we already connected to earth, now we don't feel shock. This is how 24-volt battery positive and negative cables are connected. Always we need to remember that PV cables from solar panels should not be connected here by mistake, because PV cables will have higher voltage than battery voltage. So connecting PV cables here will burn the inverter. Now here PV positive and negative cables are connected to inverter. Remember that we need to do all these connections only after disconnecting all DC AC electricity. Electrical appliances we use include fans, TVs, 1 HP water motor, induction cooker, iron, etc. 1 HP motor surge current is around 16 ampere of 230 volt. Inverter can support surge current of 7 kilowatt. This surge current sometimes increases to 22 ampere. See this video. It may be due to rotation has become more tight. Operating 1 HP motor more time is better when solar power is available. We also use induction cooker of 2000 watt. Since our solar output is around 1000 watt on average sun, we operate induction cooker by reducing power usage to 1000 watt. Next is to show you using ironing. This is an on switch. Pressing top of this switch, load is from utility grid. If bottom is pressed, load is from inverter. Iron has a power range 900 watt to 1100 watt. We can operate inverter AC if we have 50 to 60% production from existing solar panels. To operate inverter AC at night, we need to add two more batteries in parallel so that battery voltage stay at 24 volt and battery ampere would double. Existing solar panels can charge 4 batteries in summer time, but in rain seasons each panel may produce only around half of its capacity. This panel capacity is not enough, and it is better to add two more solar panels in series. What is important to mention here is that inverter is capable to provide load to even normal AC if source of power is available, and because it is 3.5 kilowatt inverter. Now we will talk about inverter screen display. When we look at the front panel of inverter, we can see LCD display, 3 LED indicators and 4 settings button. At the top part of LCD display, left part shows input source information like frequency, PV voltage, charger current, battery voltage, etc. Right part shows output information like frequency, load percentage, load in VA or watt, and discharging current. In the middle, it shows warning and fault codes. At the bottom part of LCD display, it shows a graphical representation of a source of power like solar panels, AC input, load percentage, battery charging status, battery voltage level, and AC bypass status. With LED indicators, function buttons, and inverter settings, there are more to talk about. If we include them in this video, it will be too long. So we will discuss them in another video. Smart ESS is the name of app. Here is the current graphical status of inverter operation. We can see inverter production data in chart. We can see different data analysis. We can see each data and its values generated in your required date. Now we can configure inverter settings through settings menu like system settings, grid settings, battery settings, load settings. Here is the battery settings like source of charging, battery type, etc. Here is the load setting like output source priority, which includes SBU, utility, and solar. We can set output voltage and frequency, transfer to bypass load. This is controller settings like LCD backlight, power saving mode, like this. I need to discuss with you how we configured inverter to work with battery, solar and utility power in order to reduce electricity bills. Normally people use battery backup to retain power supply when grid power fails. But I use battery backup differently with the aim to reduce electricity bill. Day or night, I never use grid power to charge battery. In daytime, I use solar power to charge battery, and both solar and battery are shared to give power to high load appliances like 1 HP motor, induction cooker, etc. If battery is charged at least 60% from solar power, there is no issue. But if it is less, there is a problem of inadequate battery power depending on power usage. To meet this case, we have configured the inverter so that when the battery voltage drops to 22 volt, which happens usually around 4 to 5:30 morning in my case, source of power for load will be transferred from battery to grid. When battery voltage reaches to 24 volt again by using morning sun, load will be transferred from grid back to battery, which usually happens around 8 am. Only risk in this procedure is that when utility power fails, that time we will have no electricity at home. But this happens very rarely. Also, when you are aware that battery is not charged well, anyone at home or remotely, you can temporarily configure output source to grid in advance by using mobile app. I have fixed inverter on the wall of a first floor and connected a 22 gauge wire to a battery monitor fixed on the wall of ground floor to watch the battery status easily. See the video. We all know that the regular fans are the main power consuming appliance at our home because fan works 8 to 10 hours continuously at night. 3 numbers of regular fans working 10 hours will require 2250 watt power. This will exhaust our battery power. In order to keep battery power longer, what I did was I replaced 3 of our regularly used induction based fans with VLDC fans. This reduced power requirement to just 840 watt instead of 2250 watt. This fan replacement helped us to reduce the situation of transferring to grid power due to battery power exhaustion. Thus, we can say that all our home is working in the solar power. Through many of my search in internet, I could not find a helpful video of an international branded inverter installed in India similar to this one. You can soon watch video of how we configure settings through function buttons and mobile app remotely. So that's the end of this video. If this video has provided to you a little knowledge and support, kindly like, share, subscribe this channel and press bell icon so more videos will reach your fingertip. Thank you for watching.